In Lesson 5.2, you're going to be solving linear inequalities by using multiplication and division. When you're solving inequalities by multiplication, just want to remind you that if you start off with a true statement like 4 is greater than 2, and then multiply both sides by the same positive integer, you're going to end up with another true statement. However, if you multiply both sides of an inequality by a negative number, the inequality symbol is going to change directions. And to illustrate that, we have 7 is less than 9, which is a true statement. However, when we multiply both 7 and 9 by negative 2, we get negative 14, and that is not less than negative 18. But if we flip the inequality symbol around, we do have a true statement. If both sides of an inequality are multiplied by a positive number, the resulting inequality is also true. However, if both sides of an inequality are multiplied by a negative number, the direction of the inequality symbol is reversed to make sure that that resulting inequality is true. Please make sure you fill in the symbols for those two concepts and make sure you have an example to show why that works. On page 293, we have an example on how to write and solve an inequality. Please make sure that you go through these steps to understand how they planned out the inequality and solved it and checked the answer. We will now do the guided practice problem on page 293. Mount Kinabalu in Malaysia has the greatest concentration of wild orchids on Earth. It contains more than 750 species, or about 1/4 of all orchid species in Malaysia. How many orchid species are there in Malaysia? So we have an unknown, which is the number of all orchid species in Malaysia, and 1/4 of those is going to be more than 750. So if we say greater than or equal to 750 species, then we can isolate our variable x by multiplying by 4 over 1. And when we multiply by 4 on the right side, we get that x is greater than or equal to 3,000 orchid species in Malaysia. In example 2, we're going to again solve by multiplying, but in this case we have a negative coefficient, and so the reciprocal is negative 7/3, and when we multiply by a negative number with inequalities, we're going to reverse that symbol. At the bottom of the page we have example 2a, and it doesn't look like it, but it is a negative n over 6 and less than or equal to 8. So to isolate the variable, I need to get rid of negative 6 here. So if I multiply by negative 6 on both sides, I can isolate the variable on the left, leaving n. On the right side, negative 48 is the product of 8 and negative 6. Because I multiplied by a negative number, I'm going to flip that inequality symbol around to get n is greater than or equal to negative 48. And notice right there it says that the solution set is n such that n is greater than or equal to negative 48. For 2b, I'm going to isolate the variable p by multiplying by the reciprocal negative 3/4. When I multiply by negative 3/4 on the left, I can isolate the variable p. And when I multiply by negative 3/4 on the right, I get positive 30/4. But since I multiply by a negative, that inequality symbol flips around. So it's p is less than 30/4, or as you can see here, p such that p is less than 7 1/2. Same as 30/4, but just make sure you have that inequality symbol as less than. For 2c, we're going to multiply by 5 over 1 to isolate the variable m. And when I multiply by 5 over 1, I do not need to flip the inequality symbol. What I have left there is m is greater than or equal to negative 3 times 5 is negative 15. The solution set for 2c is m such that m is greater than or equal to negative 15. And finally, 2d, reciprocal of 3/8 is 8/3. And when I multiply by 8/3 on the right-hand side, I get 40/3. I do not need to reverse the symbol, so I'm left with t is less than 40/3, or the solution set t such that t is less than 13 1/3. On page 294, there's a little watch out note about negatives. A negative sign in an inequality doesn't necessarily mean that the direction of the inequality should change. For example, when solving x over 6 is greater than negative 3, do not change the direction of the inequality, because in this case, we're multiplying by a positive 6 to get rid of the inequality sign. And if you're ever in doubt, just check your answer. In this case, x is greater than negative 18. And if I pick a number greater than negative 18, like let's say 0, 0 divided by 6 is greater than negative 3. That makes a true statement, and so I know that I did the right thing by not flipping the inequality symbol. When solving inequalities by division, if you divide each side of an inequality by a positive number, then the inequality remains true. However, if you divide each side of an inequality by a negative number, the inequality symbol changes directions. And so what we have here is division by a positive number, and we're keeping the inequality the same. Whereas if we're dividing by a negative number, we have to change that inequality direction. And these examples demonstrate the division property of inequalities. Please make sure that you read through this chart on page 294 and write down the symbols that go along with the division property of inequalities. Also make sure to have an example of both. For example 3 on page 294, we have an example where you're dividing by a positive number on both sides of the inequality and where you're dividing by a negative on both sides of the inequality. Make sure you read through these examples and note how that looks on the number line with an open circle and a closed circle. And pause to see if you can work out 3A, B, C, and D, and then press play to check your answers. In 3A, we have 8p is less than or equal to 58. When we divide both sides by 8, we're left with p is less than or equal to 58/8, and that does reduce to 7 1/4 as a mixed number. Notice that that's a closed circle at 7 1/4, and it's less than or equal to, so our arrow is going to the left. For 3b, we have negative 42 is greater than or equal to 6r. To isolate the variable r, we are going to divide both sides by 6. Negative 42 divided by 6 is negative 7, is greater than or equal to r. You can write that as r is less than or equal to negative 7. That is going to be a closed circle at negative 7 with an arrow going to the left. For 3c, we're going to divide by a negative 12 to isolate the variable, which means that we're going to have to flip the inequality symbol. So we have h is less than 15/12, which reduces to 5/4. And since we did divide by a negative, it's a negative 5/4. And so we have an open circle at negative 5/4 with an arrow going to the left. Finally, on 3d, to isolate the variable n, we have to multiply by a negative 2/1. And when I multiply by negative 2/1 on the right side, I get a negative 12. Since I multiply by a negative, the inequality symbol switches, and we have n is greater than or equal to negative 12. That is a filled-in circle at negative 12 with an arrow going to the right. Please take a moment to look at number 42 on page 296. Taro and Jamie are both solving 6d is greater than or equal to negative 84, checking to see whether either of them is correct. So Taro, it shows that He divided by 6 on both sides, and we have a correct answer. But Jamie is dividing by 6 on both sides and also changing the inequality symbol. So Jamie is incorrect because you do not need to change the inequality symbol when you divide both sides of the inequality by a positive number. Also take a look at number 43 on page 296. It says to solve each inequality for x. And so to isolate the x on 43a, we're going to divide both sides by a negative a. And when we divide by a negative a, that inequality symbol switches. On b, to solve for x, we have to multiply by the reciprocal of 1 over a, which is a over 1. And when we multiply by a over 1, that's a positive number. We don't flip the inequality symbol. We have x is greater than or equal to 8a. On c, to isolate the variable x, we have to divide both sides by a. And so what we're left with is negative 6 over a is greater than or equal to x. But notice that we can also write that answer as x is less than or equal to negative 6 over a.